Let's go to page 225 and start with 316. Okay, 316, it says a wooden cube with edge length n. So you have this cube with a length of n, and it's cut into smaller cubes of length of 1. Okay, and if the number of smaller cubes with just one face painted, so with one face painted would be the one here. Okay, this if you cut, so again all these are cutting. Okay, the rest one will have either 2 or 3 faces painted. Okay, so the one would be one face painted would be the one on the inside right over here, and we're going to call this x. So the number of one face, only one side painted would be x times x. Okay, and there are 6 faces, so it would be times by 6. Okay. And this is equal to the one with nothing painted. So nothing painted would be the one inside. Okay, and so the inside over here that's not painted would be the one behind these, and so it would be x times x times x. Okay. And so by doing that, since we know that x is not equal to 0, so we can divide by x squared. So we can see that x equal to 6. So since x equal to 6, and then so therefore n will equal to 8, because you're going to have one on this side and one on this side, right? So n will equal to 8, and that's it. Okay, let's go to 317. Okay, 317, the picture is giving. So you have again, it's a cube, and a smaller cube is cut out. Okay, so each one have the length of 3, and the inside has length of 1. Okay, so you can write down, so it helps you to visualize. And you're looking for the area, the surface area including the inside. Okay, so the surface area equal to 6 of on the outside. So 6 of these, because there are 6 faces, right? Plus the inside. So each of the face on the inside, let's say if you take this one, it's going to be 1 by 1. Okay, this one here, and notice there are 4 of them, so you have to times it by 4. And there are 6 of them. Okay, so each hole has four faces. Okay, and then there are 6 sides, so you have to times it by 6. Okay, so this is going to be equal to 6 times. So this area would be 3 squared minus 1 squared. Okay, and this would be just 24. So k will equal to, okay, so 9 minus 1 is 8 times 6 is 48. So k will equal to 72. Okay. Okay, let's go to 318. Okay, so a cube of side 3 inch has a cube of side 1 cut out from each corner. So what you're going to see, so you have the 3 by 3 and you cut out each corner. Okay, something looks like that. Okay, so after you cut out each corner, then you're going to put a cube of 2 by 2. Okay, kind of run out of space. Okay, so then you need to look for the total surface area. Okay. Okay, so first let's consider this cube over here. Okay, so this is going to be equal to 2 by 2. Okay, and there are 6 faces, so times by 6. Then you have to minus the corner that fit in here. Okay, so how to minus the 1 by 1. Okay, and so 1 by 1, that's one of this side. And since there are 3 corners, okay, the corner has 3 faces, right? So you have to times it by 3. So again, 1 by 1 is just one of these, right? And notice each corner has 3 faces, right? So you have to minus the 3. And there are 8 corners, so you have to times by 8. Okay, so again, 1 by 1 is one of the face. So each corner had 3 faces got covered up or touched. Okay, and there are 8 of those cubes on each corner, so times by 8. So this take care of the 2 by 2. Okay. Now you're going to add this over here. So this would be the 3 by 3 times 6. Okay. So we take care of the 3 by 3, right? Then you have to minus the corner of each one. So you have to minus the 1 by 1. Again, times by 3 because each corner has 3 faces. Times by 3, and there are 8 corners. Okay. So now it's just a matter of work it out. Oh wait, 2 by 2 times 6, and there are 8 corners, so we forgot the 8. Okay. Okay, so again, summarize again. So for the 2 by 2 cube, okay, so 2 by 2, so 2 by 2, that's big face over here, okay, times by 6 because there are 6 faces for each cube, and there are 8 cubes for one at each corner, okay. But for each of these, the corner is kind of fit into that notch. So that little notch over here is 1 by 1, and each corner has 3 faces touching. So times by 3 faces. So this is one corner. Okay, again there are 8 corners, so you have to times by 8. So this kind of take care that indentation over here. Now you have to do this cross over here. So again, so you start with the 3 by 3. Right, so 3 by 3, and there are 6 of them. There are 6 faces. Then you have to minus that corner over here. Okay, so the corner would be the 1 by 1. Okay, and there are 3 of them at each corner, and there are 8 corners. Okay, so you got 192 minus 24 plus 54 minus 24. And so K will equal to 198. Okay, let's go to 319. Okay, so 319, the picture is giving, so it's kind of nice. So let's go and draw a big, nice picture, so easier to label everything. Okay, so over here you got the, let's go and redraw this one. Okay, that's much better. Okay, so you got the A, B, C, D, G, H, F, and E right over here. Okay. Okay, so 319, this picture over here says DHG. So DHG is 45 degrees, and FHB is 60 degrees, and you're looking for the cosine of this angle right over here. Let's call it theta. Okay. Now, since no number is given and trigonometry deal with ratio, so when you deal with ratio, you can put any numbers. Okay, so if you put 1 over here, this is a 30, 60 spatial triangles would be 1, and this would be 2, and this would be square root of 3. Okay, so this would be square root of 3. And since this is square root of 3, and this is a 45-degree angle, so this would be square root of 3. And this hypotenuse would be square root, because this would be 45, 45 triangle, so this would be square root of 6. Okay. Okay. And also, so this would be square root of 3, square root of 3. This would be 1, it would be 1. And so this diagonal would be 2. Okay, again, this is your 30, 60 spatial triangle. So now if you look at the triangle, the DBH, and you're looking for theta right over here, right? So if you notice that this is a 2, this is a 2, and this is square root of 6. So this is isosceles triangle, okay? So if you were to draw, the perpendicular, this would equal to half of that. So it'd be square root of 6 over 2, square root of 6 over 2. So cosine theta would be the adjacent over hypotenuse. So cosine of angle BHD will equal to square root of 6 over 2 divided by 2. Okay, so again, it's adjacent over hypotenuse. So cosine of angle, let's call it theta. So cosine theta equal to square root of 6 over 4. Okay. Now another method of solving this problem is if you can use a vector. Okay, so if you use a vector, so okay, so you're looking for angle between the, so you got vector B, okay, so vector B would be equal to 1, so this is your X, and this is your Y, and this is your Z. So vector B would be 1, so it would be 1I plus the square root of 3j, and there's no k. And the vector D would be, you have to go up and over, so it'd be 0I, and then you're going to get square root of 3j plus square root of 3k, okay, using the vector. Then you use the dot product, okay? So B dot D equal to B D cosine theta. So when you dot product, you can find the angle between them. So cosine theta will equal to B dot D over B and over magnitude of D. So cosine theta equal to, so when you dot these, right? So you're going to get 0, right? I times I is 0. You got 0I over here. J times J, so you multiply, you're going to get 3. And K, you're going to get 0, right? Because again, this is 0K. So 0 times that gives you 0. Okay. Then the magnitude of B would be just Pythagorean theorem. So it would be square root of 1 square plus square root of 3 square. And the magnitude of D would be square root of 3 square plus square root of 3 square. Okay, so cosine theta will equal to 3 over square root of 4 and square root of 3. Okay, let me double check. Yeah, okay. So it'll be square root of 4 and square root of 6. So cosine theta, it will equal to 3 over 2 square root of 6. Okay, and simplify. Okay, and simplify. So cosine theta equal to square root of 6 over 4. And you get the same answer. Okay? So you can use the vector or you can use a regular geometry. Depends on, in this case, the geometry easier. But if you don't get a nice angle, then you're probably going to be difficult with this one. Okay. Let's go to 320. Okay, 320. A truncated octahedron is a geometric set with 14 faces, 6 congruent square and 6 congruent hexagons. So if you're wondering what it looks like, I will try to draw. So something looks like that. Okay. Now, if you consider each face individually, so there are 14 faces. Okay, so there are 6 squares and 8 hexagons. Now, if they're not jointed, then the vertex would be, so the vertex would be equal to, so like this one over here, the square has 4, right? So it'd be 6 times 4, and this one has 6, right? Each one has 6. Again, this one, if they're not jointed, if every face is separate, so the total vertex you have would be 72. So you're going to get total of 72 corners, okay, or vertices if they're not jointed, okay. But now, if you look at the shape, look at every corner. Every corner is counted 3 times. Like this corner of it is counted by this hexagon, and this square. This corner is counted by this hexagon, and this square. So every corner is counted 3 times. So that means you have to divide this by 3. Okay. So the corners, I'm going to call it C, will equal 72 divided by 3. So C will equal to 24. So there will be 24 corners. Okay. Another way to look at it is that if you notice this will equal to 6 squares, right? Notice that if you count the vertex or the corners of the square, it will account for every vertex. See that? Okay, let's go to 321. Okay, so 321, what's a regular octahedron whose vertices are corners of faces of the cube whose edges have lengths of 6? Okay, so again, you have the cube, and every edge is equal to 6, and it connects the okay, so it looks something like that. Okay, so first you kind of want to break this down into 2 dimensional. Okay, so when you look at 2 dimensional, right, the base, okay, the middle would be like this, and because this is going to be a 6, right? See, from this to here, that is the length of the cube, so that's 6. Therefore, this would be a 3, so it would be 3 square root of 2. Okay, so that's the dimension of these. Now the height, now if you just look at this pyramid over here, since this whole thing is 6, So from the base, from the middle, from the center to the top, the height will equal to 3. Okay. So the pyramid, so the volume of this pyramid would be, since it's a pyramid. Okay, let's do the base first. So base would be you can just going to use this times that. So it would be 3 square root of 2, 3 square root of 2. Okay. Or you can use the you can use the 1/2 d1 times d2. Okay. You can use a rhombus. Okay. So so you got the side times side, and then you times it by the height, which is the 3, and you have to times it by 1/3. Okay, because it's a pyramid. So this is for the top half. Then you have to times it by 2. So again, so the base is a square, so side times side, and times by the height. Okay, because the height, this is total is 6, right? So height is half. Okay. So side times half, and it's a pyramid, so you have to times by 1/3. And there are two of these, right? 2 pyramids connect to each other, so times by 2. So this will equal to, this cancels out, and so this will give you 36. Okay, so it's just a matter of able to visualize and see the shape.